Hello everyone, welcome to the class. I hope the audio and video are fine. Please, if you are able to hear me properly. So we'll wait for. Okay, everyone, beginning with today's class. So, today we are going to talk about one of the paradigms which are there in psychometrics. So, there are two paradigms which are there. There is classical test theory that we are going to discuss today, and there is item response theory IRT that we will be doing in the next class. Today we are going to focus specifically on classical test theory. So classical test theory has to do with our psychometrics. It has to do with the reliability assessment that we have, etc. So this classical test theory was actually proposed by Charles Spearman in the year 1904, where he was actually willing to give a particular method in regard to how we can calculate the reliability of our particular test. So it is a traditional approach. The newer approach is item response theory that we will be doing in any another class, and it helps us in testing and calculating the reliability and validity of a particular space. Now, this theory is also known as true score model or theory of true and error score. Now, if we look at a particular individual, we are not all perfect, right? So, whenever we are, doing any particular kind of test, or for example, if you are attending or maybe giving a particular exam, like we are fallible, right? We make mistakes. So, whenever we would be undergoing any kind of measurements, even if it is any human trait or even if it is an attribute, there can be some error which can be there in the observed score that we have. So whatever score that you would be getting, which would be the observed score, would consist of both the true ability or the true score that you have for that particular trait or that particular aptitude, like that particular attribute, and it would also consist of some kind of error, right? Now that error can be systematic also, and that error can be just by chance also. Okay. So in this particular theory, Spearman has actually taken into account the fallible nature of human beings and why the observed score will include the error score as well as along with the true ability. So till now we have learned that the observed score, this is the equation that we write, x or observed score is equals to t plus e, where the t basically tells us about the true ability or the true score of a particular person on any attribute, any measure, etc. And error actually depicts the error made by that particular person. Now it is not necessary that that error would always be negative in nature. That error can be positive in nature as well as negative in nature. Why and how? For example, you were giving a particular test, and a friend of yours actually told you that okay, this is the answer to that particular MCQ. So you scored a +2, right? So this was a positive error. which actually showcase your observed score to be 2 marks more than the true ability that you had, or the true knowledge that you have had of that particular knowledge. But there can be other times also. For example, the examiner that tested actually did not give you enough marks that you expected, or maybe for example the examiner distributed the papers really less, due to which you lost out on 5 marks. Okay, you were not able to attempt those particular scores. So the error, whatever error that you make, can be positive in nature and it can be negative in nature. So now, according to Charles Spearman, whatever errors that we make, they are random. Okay, and they can be positive or negative, as we discussed. So if I plot all the errors that are there of all the individuals, or whenever I conduct my particular scale, any intelligence scale, any measurement, etc., on a large sample, that would kind of cancel out, right? So the mean of the error would always be 0. This is the first feature or the first assumption of our classical test theory, that all the errors combined would be 0, right? Now this error score, the second assumption is that the error that we are having, it can be positive, negative, any kind of error that we have, will not be correlated with our true ability or our true score. So they are both uncorrelated. The third assumption or the feature that we have is that the true score and error would also be uncorrelated. Like by default, if we talk about the second point, by default the true score and the error would be, like here we were talking about true ability, here we are talking about true score. So they are unrelated to each other. Then the error that you will commit on different tests would also be uncorrelated. It does not mean that your friend helped you this time, they might not help you the next time. So the error on different tests would also be uncorrelated. Now the main assumption or the main idea on which this particular theory is based, that the true ability of the person, the true score of the person that the person was supposed to have, would never change. For example, if I was calculating the IQ of the person, so if they were supposed to get, like there is observed score is equals to true ability plus error, or the true score plus error score. So if they were supposed to get a 90 on that particular scale, and maybe by chance they had a error, positive or negative, whatever error, due to which their score increased or decreased, whatever, but the true ability that the person has will never change. It will remain constant. If you talk about reliability, what is reliability? Reliability is consistency of scores, right? So whenever we are calculating the consistency of score, and whenever we are talking about the true ability or the true score on a particular measurement or a particular attribute, it will never change. It will always remain the same. And as we mentioned, the mean or the average of all the errors would be 0. So the error is randomly distributed, which means that the mean is 0 and standard deviation would be 1. And at last, the true score and the observed score would have a linear relationship. Okay. Now, keeping this classical test theory and the various assumptions that we have taken into account in mind, we calculate reliability. There are various factors that we take into account. Okay, so there is a formula that undertook, or that is there, that we highly used to calculate the reliability of a particular test, which is that the true variance or the true score that we will be getting divided upon the obtained score. Okay, or there is another version of the same particular formula is, wait, my screen has frozen. Okay, so there is another version of this particular formula is 1 minus error variance upon obtained score. So these are the two formulas which are there for calculating reliability, which has been derived by this classical test theory, right? So there is this whole derivation. I'm not going to do that whole derivation, but the answer would always be, you would not even be asked for the same. You should just know that if we have the observed score is equals to the total or the true ability plus the error made by the particular person. So if I have to calculate the reliability would either be calculated by this particular formula with true variance, the true ability which never changes, which remains constant, divided upon the observed score, obtained score by the person, or there is another version of the formula where 1 minus error variance upon obtained score. Now this particular classical test theory has two implications. The first implication is domain sampling model. So this domain sampling model basically deals with the creation of a limited number of items. We do factor analysis, right? Why do we do it? We do it to create a limited number of items which will actually measure the large construct or the large ability, right? So we need to have a limited number of item, a small number of item to measure a large construct or to measure a large attribute or a human measurement. So as we have learned that this particular model, the classical test theory, basically conceptualize reliability to be the ratio of the true variance upon the observed variance on a shorter test. So if I am using a test which is very, very small, I would just take this into account, and same goes for the longer version of the test as well, right? So if I am, as we talked, that the error would be random, right? So if I am using a scale on a large number of population, if I am using a longer version of that particular scale, we just need to calculate the variance of the observed score. But if I am using a shorter version, then I would use this particular formula which we have made, where true variance would be divided with obtained variance, but on a longer version of the scale, the variance of the observed score would also get us the reliability. Okay, so here all the sample of the items are evaluated rather than the whole sample of items are evaluated rather than the whole test. So for example, we were using a longer version of the test. So if there were 100 questions, I would take a sample of maybe 10 questions and then conceptualize reliability from them only in accordance to. And we have also learned whenever we learn reliability, we know that the number of items, whenever we increase the number of items, the reliability also increases. ठीक है, and we would also increase the sample size if there are more number of items. So this is its implication in the domain sampling model. And classical conditioning, classical test theory, I'm so sorry, classical test theory also has a second implication in parallel tests. So there we make two particular parallel tests, for example, and here the true score, here we have two assumptions. The true score would be same for both the tests as they are measuring the same construct, and according to classical test theory, the true ability never changes. So if there are two parallel tests, this true score would remain same for both the tests, right? It would be equal to that of the another test, and second, the error would also be equal. So error is also equal for both the tests, true score is also equal for both the tests. So can we say that the reliability of the one test, the first parallel test, would be equal to the reliability of the second parallel test? This is its second implication. So that was majorly about classical test theory. Classical test theory has been proposed by Charles Spearman in the year 1904. And this is also known as theory of true and error score, true score model, and it helps us in the conceptualization of reliability and validity. It conceptualizes that the observed score on any measurement, any attribute, is made up of the true score of the person, the true ability of the person, and the error which is committed by that particular person, or because of the, like, it can be systematic or it can be random, and it can be positive in nature, negative in nature. The error would be randomly distributed, the mean would be 0, standard deviation would be 1, and our true ability would never change. And at last we conceptualized on this particular, these two formulas of reliability which have been derived using classical test theory, which is true variance upon obtained score, or 1 minus error variance upon obtained score. And it has two implications in terms of domain sampling model. We can just use a sample of item to conceptualize reliability instead of using the whole scale, or we could also use it in terms of parallel testing. So that was about it. If you guys have any query, you may ask, and then we would wrap up the class. Of domain sampling. Okay, then I think we should